All right, everybody. So this is the section 5.1, probability distribution. This actually is a really easy section, which is great. It's not going to take too long to deal with. Once we do some examples, you'll see it's actually pretty easy to deal with. But the main thing about this section is a little bit of background information. So a probability distribution. So when working with a probability distribution, we must always verify two conditions. So that's the key thing. We must always verify two simple conditions we're going to talk about right now. The first is the probability of each x, in other words, p of x, is any number within the range 0 to 1. So we already know that for sure, right? It's from your exam. A probability must be between 0 and 1. So that's always the first condition itself. Okay. The second rule is the sum of all of the probabilities must equal 1. That's another key concept there. So discrete probability distributions are finite and countable when x is the value of each discrete outcome, and p of x is the probability of each discrete outcome. So a little gibberish, don't worry about that, but the main concept we want to talk about is these two things here. And we'll do some examples so you can verify those respectively, okay? First off, so these discrete probability distributions can be organized in a table with each possible x value listed on one row and the associated probability p of x listed on the bottom row. Now, when it comes to this, you can either go across like you see it here or go down, and I'll show you guys the difference between going across and down in a little bit as well. Okay, but when it comes to it, I give you guys a quick little summary of what the most important thing is, right? So the sum of all the probabilities must equal 1, and then and each probability must be between 0 and 1 as well, right? So those are two major concepts we're dealing with in this section here, okay? Focus, a little bit better, okay? All right, so here's an example illustrating that as well, okay? So the example is x is the numbers 0, 1, 2, 3, and 4, and each respectively, this is the probability of 0 happening, 1 happening, 2 happening, 3 happening, and 4 happening. So the question now becomes, is this a probability distribution or not? So in other words, we have to verify these two things. So first off, all the probabilities are between 0 and 1, right? Each one is between 0 and 1. Okay, so that's a check, so that works, right? So they're all the same. Next step is, if I add them all up, do I get 1? So what happens if I add this, 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 and this together? What will we get? So I believe the answer is in the back. Oh yeah, so that would work, right? I think this is the answer. So yeah, so if you add this, that gives you exactly 5 over 5, which is just 1. So check. That's an example of a good probability distribution. Okay. So now if you turn the page, these are examples when they're not actually itself. So a lot of these are not itself. So example 1, verify if the given probability distributions are valid by checking the three conditions itself. So, oh, I forgot one more thing, the third condition. So real quick, the third condition, I forgot to write this down, is all x must be shown. Okay, and we'll talk about what that means, I believe, in the next example, so you can see what it means by all x must be shown. So that's a 3, sorry. 1, 2, and 3. Okay. All right. Now let's go to this example here, A. So A says the number it lands on when rolling a die. Okay, so rolling, so again, we're assuming it's a 6-sided dice. Okay, all right. So first condition is the sum of all the probabilities. So the sum of all the probabilities, right, equal 1. So if I add all of these up, do I get 1? And we should, right? This should give you 6 over 6, so that's equal to 1. So check, the first condition holds. Okay. All right, second condition is every probability between 0 and 1. It seems so as well, right? They're all 1/6, so it's between 0 and 1. And then finally, the third condition is what I just talked about right now, is all x must be shown. So let's think about that. So if I roll a 6-sided dice, what are the numbers that come up? Well, 1, 2, 3, 4, 5, and also a 6. So notice the 6 is missing, right? Which means it's not showing all possible x values we can have. So that's what the third condition means, is if x must all be shown, is all the possibilities must be shown as the x values themselves. So since 6 is not included. Therefore, it is not valid probability. And again, it gives you a summary as to why is it there, right? So in this case, the 6 is missing in the x values themselves. Okay. All right, and we keep going, right? There's a couple more examples. Question 2, the number of multiple choice questions answered correctly out of 5 questions. So pretty good, 0 through 5, right? You can get 0 wrong, or you can get all of them correct. That's good. All right, so first condition, if I add them all up, do I get 1? And hopefully you guys say, should I believe? I think it works. Let's check. So 0.3 plus 1.1 plus 0.1 plus 0.2 minus 0.9 plus 0.2. Yep, you get 1. So that works. So first condition holds, second condition holds, so check and check. Okay. Last condition is all of them between 0 and 1. And hopefully you noticed there's 2 that does not work. This is not between 0 and 1, and that is not between 0 and 1. So therefore, it is not a probability distribution. And that's what it says at the very top of the next page, right? The probabilities P of X's values are not below, are not between 0 and 1, right? One's below 0 and one is above 1. Okay. All right, let's do a couple more, and then you guys can do a couple on your own. So C. So the number of shots made when a person throws the basketball 3 times. All right, so again, right, you can have 0 shots up to all 3 of them. So that works, so check. Right, so if I add these up, do I get 1? No, you don't, right? This is 0.6, 0.7, 0.9. Not equal to 1. So automatically, because of that, it is not valid, right? Because if you add them up, they do not equal 1. Okay. All right, and the last one here is D. So D says the number of true/false questions answered correctly out of 3 questions. Okay, so again, you can have 0 correct or all 3, so check. All right, next thing is if I add them all up, do I get 1? So do we? And I believe you do not, which is the answer, is it? Here's 168. Oh yeah, here's it, 68, which is, oh yeah, this one does work, sorry, does work. That gives you 1, right, when you add them. And then each one is between 0 and 1, so therefore it is okay. This is a probability distribution. Okay. So like it says on the next page, 68, very top, it is valid, right? All 3 conditions are actually hold. Okay. So just quick little, examples illustrating. Most part of this is just, your homework is just going to be verifying, and the other part is actually finding itself. And that's what we're going to be doing in a little bit, actually constructing it from scratch. But the first part is, just simply, breaking it down. Do you know what this means? Do you know what that means? A couple definition-wise, right? Things like that. All right, so now I want you, what do you guys do? Let's try some on your own. So this is a little off. I don't know why the printer did this. Some of you guys have this. So this question A, and you may have a complete blank page on page 69. Just flip it over. It's supposed to be on page 70. So come on, focus. Okay. So this A should be attached to page, the one on top of page 70. So they should be like together like that. Okay. So I'll give you, go and pause it and do A, B, and C on that portion. So 3, 2, 1, go. Okay. So hopefully you guys tried them, and let's try these out together. Okay. So A says out of 5 attempts, the number of goals scored when kicking a soccer ball. All right. So good, right? You can have 0 goals or all 5. So check for the first one. Next one, if you add them all up, do you get 1? So let's see. So you get 0.31 plus 0.52 plus 0.1 plus 0.27 plus 0.4 plus 0.2. And you do not, right? You get 1.8, which is not 1, so this is not valid. Okay. Okay. Go on to B. B says the number of boys in a family that has 3 children. Okay, so quick verification, right? So this actually is true, right? For the X's, you can have 0 boys or all 3 boys, so check, that works. All right, next step is if, well, notice it already fails 1, right? You only have to check if they added equal 1 because that is less than 0, so that's automatically not valid, right? Because it has to be, all of them has to be bounded between 0 and 1. Okay. All right, and the last one is cut off again. I don't know, the stupid printers at work. All right, so it should look like that. Okay, so C is the number of games a football team wins out of 6 games. Okay, all right, so first off, you can have 0 losses or all 6, so check, that works. They're all between 0 and 1, so that works out, right? So then the question becomes, well, are they all equal to 1, right, if we add them all up? So let's find out.